Hello, everyone, and welcome to this session where I'm going to tell you about how Delta Lake with Azure Databricks can accelerate your big data workloads. My name is Kyle Weller. I'm a product manager on the Azure Databricks team at Microsoft, and I am super excited to be here with you to tell you all about Delta Lake, which is one of the specific technologies and features that you can take advantage of within Azure Databricks. But I'm also going to give you an orientation and overview of what Azure Databricks is, show you our roadmap, things that are exciting that have just recently been released, and talk about the things that are up and coming. So let's dive in. Now, if you are new here and you're wondering what is all the buzz about with one of the hottest products on Azure, let me give you a quick introduction. If you have data and lots of it, Azure Databricks is going to be your new best friend. It is a high-performance, limitless scaling, big data processing and machine learning platform. So whether your goal is to extend into untapped sources, gain insights in real time, or perform advanced analytics, Azure Databricks has you covered. Azure Databricks is collaborative. You can create workspaces with advanced role-based access controls, create collaborative notebooks, and integrate deeply into CI/CD DevOps processes within your entire team. Azure Databricks is connected. You can, this is a first-party Microsoft product that we have engineered native connections with almost all other services within the Azure portfolio. Here on the screen are just a few examples with our native connections with Azure Data Factory, Azure Synapse Analytics, Azure Data Lake Storage, Power BI. I'll talk about a new and improved connector that we have released recently. And of course, you can leverage all the popular open source tools that are out there, PyTorch, TensorFlow, scikit-learn, to do advanced machine learning as well. Azure Databricks is fast, really fast. We're going to spend a solid chunk of time here today highlighting some of the new advanced innovation that we have been pouring into the Azure Databricks runtime and beyond. And of course, Azure Databricks is secure. With a wide variety of industry-leading compliance certifications, you can feel comfortable that our security has been scrutinized and vetted by third-party auditors even to meet the highest standards. Azure Databricks applies to a wide variety of use cases. I've talked with customers across all these different industries, and every single time I meet with someone that is using Azure Databricks, I am surprised and my eyes are open to the new ways that people are leveraging data to expand their businesses, to make impact to their bottom line, to help their customers, and really change the world. It's really, truly mind-blowing. I won't read everything on this slide, but you can just imagine how Azure Databricks, if you have data and you use Azure Databricks to take advantage of that data, you can, if you are in the retail industry, do things like real-time pricing optimization. If you are, in the advertising kind of business, you can do real-time ad. You can build a real-time ad bidding platform and change the way that you're pricing products on your page dynamically. As the ad traffic comes through, as people visit the sites, learn about your customers and have a full 360 customer view analysis. The sky is the limit here in terms of the use cases, since Azure Databricks is, a general purpose compute engine. So if you have data, you're going to find a use case and you're going to find a way that you will make a significant impact to your business and bottom line. Let me just show you the high-level architecture of where Azure Databricks fits in with the rest of the Azure portfolio. This will help us, this discussion will help us understand what Azure Databricks is, what Azure Databricks is not, and this is kind of like a recommended architecture pattern of where we see customers succeed when they are building their end-to-end data estate, their end-to-end data journey. If they leverage some of the concepts here and constructs, they will have successful architectures built for their data estates. So looking at this journey, of course, everyone always starts with a wide variety of data sources. You're going to have data coming at you from all different angles. You'll have data that is coming from sensors and IoT data, perhaps coming in at real time. You're going to have logs that are structured or unstructured, various files. You're going to be pulling in data from third-party partners that you collaborate with. Even looking up, I've seen many customers pulling even things like weather data or Twitter feed data from all kinds of places. Now, you're going to want to take this data, ingest it, bring it in, and start creating a centralized data lake on Azure. So tools that you may use to leverage this are things like Azure Data Factory. It's an amazing ingestion tool that has a wide variety of connectors, and it makes it seamless. It gives you a seamless way to bring data onto Azure and get it into the cheap, reliable storage that is Azure Data Lake storage. If you're using real-time data and connecting to real-time data, you might use tools like Azure Event Hub or Azure IoT Hub. If you're familiar with Apache Kafka, similar idea here. These are real-time messaging buses that you can think of them as giant buffers in memory that real-time data will come in, and you can have this data sent down to your data lake storage, but at the same time you can keep it on the hot path, and as data comes in you can be processing it in real time, and I'll tell you more about that as we dive in. So once your data is in here, this is where Azure Databricks comes into the picture. Azure Databricks you're going to use to explore this data, to clean this data, to transform this data. You can leverage Azure Machine Learning, ML Flow. You can start to apply advanced analytics and machine learning on this data. You can train machine learning models and even deploy these out to Azure Kubernetes services. You're going to take data that you have transformed and prepared. You might load this into more of an operational data store like Cosmos DB or SQL DB. We have connectors that make it easy for you to send data further downstream to these kind of serving layers. Perhaps you need to power some real-time line of business applications, and if you need an operational data store as that serving, Cosmos DB, SQL DB, these are going to be go-to platforms that you may want to consider. Now, if you are looking to solve enterprise BI kind of solutions, you want to distribute BI reports across many people within an organization. Maybe you need to have BI scenarios powering even externally downstream users that you have. We also have native high-performance connectors built, co-engineered with the Azure Synapse Analytics team. So if you, this is Azure Synapse Analytics, if you haven't heard, is our next generation data warehouse technology. So Azure Databricks and Azure Synapse Analytics work well together when building a modern data warehouse pattern to succeed in enterprise BI solutions. So really exciting stuff. Hopefully this helps you see the high-level picture, what Azure Databricks is, and where it fits in. Let me tee off as well. Some of you are already familiar with Azure Databricks, and I want to hit some of these top announcements for you before we dive into the nitty-gritties. Each of these top announcements I will go into more detail about as we go in through the next slides. The first one being this year is a really exciting year. We released the Databricks Runtime 7.0. I think we're up to 7.4 at the point in time of this delivery. With Apache Spark 3.0. Apache Spark 3.0 is jam-packed with new features, some really exciting things, and we're going to talk about some of these like adaptive query execution, dynamic partition pruning, so many more game-changing breakthroughs. People were really excited for this Spark 3.0 release. The next one that is very exciting as well is Delta Engine, our new Delta Engine with Photon. I'll show this in a few slides and showing you how we've built off of a Spark 3.0 and enhanced Spark performance even further. Now, SQL Analytics. You may have read some of our recent blog posts about this. Previously, we may have referred to this as Redash. This is a brand new experience we're releasing soon that will offer simplified and powerful SQL environments to help business analysts feel even more at home. Workspace 2.0. is an exciting evolution in our advanced new feature set aimed to increase the productivity of data scientists. I'll show you some of these features in a few slides as well. And last but not least, I want to give a shout out to all of our potential federal customers out there. We are in public preview on the Azure US Government Cloud, and we'll be hitting our GA release very soon. So we've also received FedRAMP High certification for this offering. This is a super rigorous certification, so I'm excited to share that news with you today. All right, now diving into each of these individually, let's start with Apache Spark 3.0. This is the next big release of this open source technology that comes just in time in 2020 for Spark's 10-year anniversary. There are a whopping 3,400 community patches that have gone into this release, and there are so many features that I don't have enough time to truly do it justice during this session, but I want to share a couple highlights with you. The first being adaptive query execution. As you know, Apache Spark and Azure Databricks uses a separation of compute and storage. This means that estimating data extraction and arrival can be unpredictable from a simple query plan. There can oftentimes be absent or inaccurate data statistics about the data, which leads to misestimated costs at runtime. Adaptive query execution improves performance by changing the plan during runtime as your data is being processed. It does this via dynamically coalescing shuffle partitions, switching join strategies, and can optimize and parallelize skew joins as well. The second one on this list is dynamic partition pruning. When you have star schema workloads, you are most likely joining facts and dimension tables. When doing this, you can filter out many partitions and skip over them when processing your data. In Spark 2.4, this decision has to be made at compile time, and to be safe, it often results in longer scans over data that you just don't need. In Spark 3.0, as a job is processing, it can adapt and prune that data out of your scans. TPCDS benchmarks show that this can lead up to 18x performance improvements. As you can see, we could go on and on for hours on these updates, and really the depth of this content should better be served in a 300 to maybe 500 level depth session. So please go watch some of the keynotes and sessions from the most recent Spark and AI Summit to get deep into this awesome Apache Spark 3.0 release. All right, next, let's dive into Delta Lake, one of the core focuses for this session. First, I know you're here listening because you have data and you need to make sense of it. And as we discussed already, the first step in your journey is to get this data into a centralized data lake on Azure. Maybe you're thinking, well, we already have a data lake and it has lots of data in it, but honestly, it feels more like a data swamp. It's unreliable, hard to govern, takes a long time for my data engineers to extract any value out of it. If you're thinking any of these things, it might be because you haven't used Azure Databricks with Delta Lake yet. Okay, now some people can get confused by the name of Delta Lake at the beginning and think they have to store their data in a new location. This isn't true. You keep your data in the same storage of your choosing, ADLS Gen 2, blob storage, etc. You can think of Delta Lake more as a storage format technology. You can take data from any format, whether it's CSV, JSON, Avro, Parquet, and upgrade this to the Delta format. When you do, there are a couple of benefits that I want to tell you about. First, you are adding, what we're doing under the hood is we're taking data that is still in Parquet files. We're not changing the type of these files. They're still Parquet files under the hood, but we keep versions of these files. And we build a transaction log, and we supply additional indexes and stats around this data and transaction log. Now, let me tell you the benefits, the outcomes of what you get here. First, think of the promise of a data lake, the central source of all data, democratized, shared, and accessible by employees across your whole company. Traditional data lakes in Spark offer no concurrency capabilities, but because we have version files and a transaction log, we can promise ACID transactional guarantees and enable simultaneous concurrent reads and writes on all your data. Another problem with traditional data lakes is things start to get messy. Delta Lake offers various levels of schema enforcement and evolution control, allowing you to set guardrails but still be flexible when you need it. We offer you efficient upserts with blazing fast and simple merge and insert commands. And with version files, you have the ability to travel back in time and reproduce data or immediately roll back to a prior version of data without having to reprocess. The next two benefits are uniquely available in Azure Databricks, file compaction and Z-order partitioning. I'll tell you more about these in the next few slides, but first I just wanted to show you this overall picture to tell you about the main benefits of Delta Lake. You can see that it is easy to get started here. You started with a data frame that could be from any source, CSV, JSON, Avro, whatever, and you change one line of code here. Instead of saying .write.format Parquet, you say .write.format Delta, and your data is automatically transformed into this new format that supplies all of these benefits and more. I'll go into depth on some more of these right here. So going off of that to dive into the performance benefits that come from the file compaction and this Z-order command, let's go into those and see how you can achieve up to even 100x performance gains. So partitioning, everyone that has been using Spark is already familiar with the basics of partitioning, where you can partition on low cardinality columns, and you're trying to aim for about a gig per partition. But we now also have this second dimension of partitioning that we call Z-ordering. So Z-ordering, you can actually pick a high cardinality column, and this will co-locate data next to each other in the files. It's going to reorganize the data within your files so that you can enable this concept of data skipping. What happens is, the query plan comes in and you have certain, filters, where clause filters, or group bys or joins or whatever it is, that when the query optimizer comes in and says, oh, we need to grab a subset of the data, let's look at the indexes and stats that we wrote around your version files, and we can say, oh, for, you've got this filter condition, we only need to extract data out of this subsection of this file. So not only can you skip over files, but you can skip over subsections of files and enable this amazing data skipping. We have real customers out there that have achieved, up to like 90%, 95% data skipping over terabytes and terabytes of files, and which led them to 100x kind of performance gains there. The other one that you have in combination here is this new command called optimize, which will take care of file compaction for you in the background. What happens when you're using big data compute systems like Hadoop or Spark or these others? You'll start to run into this small files problem, where over time your data is spread out. A small amount of data is spread out in many small files. Apache Spark is not optimized to handle this situation, and it will lead to performance degradations over time. So this command built in, if very simply you see on the screen here where it says optimize events, you can even put conditions on this. In the background, it's going to take all those small files and compact them into, it will analyze and compact those into just the right size files that Apache Spark wants to have in order to maximize the performance throughput. So you can schedule this compaction job to run on a periodic basis based on your needs. You can run it in separate clusters. It will have zero impact to the performance of your other jobs, zero impact to the availability, uptime of your data platforms as well. Super powerful, exciting functionality. All right, let's take a peek at the transaction log under the hood. I want to show you a couple other components about Delta Lake here. You'll see on the left-hand side, this is an example of what the transaction log looks like. You will see, like if you dove into the file system, you would see a folder, for your table. This is my table, it's a folder. Underneath this folder, you'll see another folder for the it will say underscore delta underscore log, this transaction log. And these are individual commits in that transaction log, 0.json, 1.json. These are those commits. So when you write a query to get data from my table, it will come in, it will look at 1.json, and 1.json will tell it which versions of the files to read data from, and if there's any transformations that need to be applied. And then you'll find your actual data saved in Parquet file format. In this case, there was a partition applied on date. So you might see like individual folders based on the partitions that you chose. And then you'll find your data here as Parquet files, still preserved as Parquet files. So you can imagine as you start to apply new transactions, maybe you add some data, add some new data in here, and you have a commit .json. Maybe you remove some data and take a couple more actions. You're going to create another commit. So this is to paint that picture for you of what this transaction log is really looking like or doing underneath the hood. Let me talk about a couple new things that are here for Delta Lake. One of these, because the promise here is to make your data lakes reliable and of high quality. So we've got a couple awesome features around this. One is about column constraints. Okay, so if you're creating a table and you can start to add constraints on the columns to enforce data quality. So this example that's on the screen, if you have an events table and you want to make sure that a certain ID is valid, you can say put a constraint here, the constraint being called valid IDs, that checks if the ID that's going to be written here is above 1,000 and less than this large number here. And by doing so, this can enforce the quality within your data. You can even then come say, hey, describe the detail of my events table. Tell me you can check what constraints are there. You can add, modify, delete constraints. And you see this is the output here when you're describing that. It will have a properties object which contains the list of constraints that you have applied on this table. Similarly, we are also soon to release this concept of setting quality expectations or expectation rules. So you can write code similar to what you have down here, where you can tell a table or to look for individual rows that meet your expectations. So in this example, you're setting an expectation for a valid timestamp and defining what valid means. Because you, as a data steward, you will know what your expectations are, and we're making this free for you to define. So you can say, hey, a valid timestamp for me is a timestamp that is greater than January 1st, 2012. And if any timestamp comes into my system that is less than this, that's not, I don't expect this, and please tell me about it. Tell me if this ever happens, because you want to be aware of that. So you can even tell it to, hey, expect or drop, expect or fail. You can tell it to discard this data. You can tell it to fail, tell your data processing jobs to fail if it encounters this data. Another one that is soon to be released under development is being able to quarantine this data. So if an unexpected timestamp comes into your data pipeline, you can tell it to quarantine in a separate table and have your data engineers come in and analyze why it was unexpected, where it came from, and decide whether to merge it back in with master or not. You can even get statistics about how your expectations are performing. Here, this is an example of UI. It says the number of records that came through, how many of those were valid, how many of those were unexpected, but you still allowed them through, how many were unexpected and you chose to drop them from the data as well. So this is tremendously valuable. I myself have played roles that are similar in my career. I've played roles that are similar to those of data engineers and otherwise, and I can just imagine walking into the office, or now it's all virtual, signing in on my laptop and checking the first thing when I come in, check how's the quality of my data. Tell me what the quality of my data is it meeting my expectations, instead of finding things last minute that have already popped into some downstream report that some executive is reading, and now we've got to walk back and figure out where our data pipeline has gone wrong and correct it and reset expectations. Maybe we've lost some trust with our stakeholders. Here I get a really fast, crisp view at if my data is meeting my expectations, and I have fine-grained controls in my hands, and being able to manipulate, contain, control, and monitor the quality of my data. This is super powerful, super exciting. Let's talk about time travel a little bit. I mentioned this as one of the benefits you get from Delta Lake. And here I want to call out some of the applications of when time travel would come into handy. Maybe you need to audit some data and get some audit history. Maybe you need to be able to reproduce some data as it was in the past. Maybe you need to debug your data pipelines, and you're even able to achieve like immediate rollback capabilities. So the idea here, the example code that's on the screen, you can say select some data from my table and then specify a timestamp as of a time in the past. So you can immediately go back and reproduce data to be as it was in the past. That's why we call it time travel. You're kind of looking at that data from an old period of time. So being able to inspect these different things is pretty powerful. Taking a deeper look at this to audit the data changes, you can come and say on your table, you can say for your events table here, you can say describe history of this events table. It will tell you all the users, their names, what operations they performed, what parameters were in these operations, what notebook it came from. You get fine-grained audit kind of history about what manipulations have happened to your data in the past. I talked about data reproducibility, the ability to say, hey, this data looks a little bit off here, but it didn't look like this yesterday. What went wrong? Maybe there was some double pump of this data. You can go and reproduce this data as it looked in the past and double check your assumptions. Or maybe you're even a data scientist and you need to retrain a model using the same data set as it existed in the past as well. Immediate rollbacks, you can take a snapshot of data in the past and say, insert into my table while selecting from that same table as of a previous version, a previous timestamp. And you can even do this for subselection. You could say, maybe just user ID 111, I need to roll back his data to a previous state. And you can do that just for an individual user as well. All right, I know this is a lot of information about Delta Lake, its capability, its offerings. Let me also just show you a high-level view at how you're going to build your Delta Lake at scale on Azure. Let me walk you through step by step, make sure that this sinks in and this lands for you. So again, this is similar to what we looked at in our high-level architecture diagram. You're taking data from a wide variety of sources, loading it into Azure Data Lake storage in its raw format. Then, using Azure Databricks, you can combine batch and streaming data at the same time. You can save this data in the Delta Lake format. Now, if you do it at this step without adding any business logic, you automatically now achieve data close to your, rawest form that has the enhancements of the quality and performance benefits that I just described. So this is really powerful. If you ever need to go back to the source, you can go back to the source in the Delta format and have those amazing benefits. Now you can start aggregating this data, enriching it, cleaning it, transforming it, using machine learning and applying predictions on this data. And you can imagine building this iterative pipeline. So there's this concept of bronze, silver, gold. You don't have to have 3 stages. This isn't some explicit rule or guidance, but it's just calling out how you can build iterative data pipelines. And now, like at each of these stages, you have just democratized this data that you can then share across your company because it has concurrency control, audit history, all those other benefits. So super powerful. From there, then you can send it on down to your other serving layers as usual, and make use of this data from there. So really, really exciting stuff. Let's move in to talk about Delta Engine. This might be one of our most anticipated points of discussion. First, I want to discuss the motivation behind developing Delta Engine, because this is a serious investment and it's a differentiator for our customers. So I want to highlight why it is important to you. When developing software, it is important to deeply understand hardware trends and where advancement is happening to ensure your software will keep up and capitalize on this innovation. Many of you as engineers listening to this session, you know this is so true, and you're thinking about this every day. So looking at a few dimensions in hardware trends shows 10x improvements for networking and storage performance, but CPU clock speeds on their own have remained the same. But we know CPU performance improvement isn't stagnant overall, otherwise you wouldn't buy a new computer, a new phone every year, right? So where are CPU innovations going? And some of these innovations are going into data level parallelism, referred to as SIMD register width. This allows an instruction to be executed on multiple data points simultaneously. Also, under the hood, there's this thing called instruction level parallelism. This allows multiple instructions to be executed at the same time. So to take advantage of these future directions of hardware innovation, I want to introduce you to Delta Engine. 2020 is a huge year for Azure Databricks because not only do we get the incredible benefits of new Apache Spark 3.0 and all the great new things we've been adding into Delta Lake, but now Delta Engine builds on top of and extends Spark performance to a whole new level. It is 100% Spark compatible, maintaining easy portability of your code with no lock-ins. Delta Engine is composed of three main components. It has an improved query optimizer, a new Delta caching mechanism, and coming soon in 2021 is a native execution engine we call Photon. So let's talk about each of these. First, the query optimizer it extends the functionality already in Spark 3.0 that we briefly talked about with more advanced statistics that increases performance up to 18x in star schema kind of workloads. Delta caching layer automatically chooses which input data to cache for the user, and it transcodes it along the way in a more CPU efficient format to better leverage the increased storage speeds of NVMe SSDs. It's this transcoding within the caching that really makes the difference, because there's many different layers of caching that we already provide and additional caching that we'll continue to innovate on. But here, this transcoding, this delivers up to 5x faster scan performance for virtually all workloads. No additional changes needed. Now, Photon, we have completely rewritten the Spark execution engine in C++ to maximize the performance improvements of modern hardware development across data and instruction level parallelism that we talked about previously. So this was previously all happening in Java on JVMs, and Python and R, these things don't natively run in a JVM, and so there's going to be overhead and bottleneck at the CPU level. With this rewrite in C++, we can get so much closer to the hardware and really have a tight loop to take advantage of these new innovations. So now we can, break out of the constraints of our CPU bottlenecks, keep pace with CPU innovations, and continue to push performance boundaries. But let's talk about impact. Let's make this real instead of just, my fluffy promises that are out there. We have run 30 terabyte TPCDS benchmarks, and we have excellent results to share. First, take a look at how using Spark 3.0 versus 2.4 with no other configurations results in about 2x performance improvement. again take the same workload and run it in Azure Databricks with the Delta engine, and again immediately another 2x performance improvement. Now looking ahead, this same workload running on our Delta engine with Photon squeezes again 4x more improvement versus Delta engine as it is already today. Overall, this results in 20x faster by default than any other Spark service that's running on vanilla open source Apache Spark 2.4. 20x improvements from the far left to the far right. This is truly incredible. Now I know this chart only talks about performance, but take a step back for a second and realize how this will also impact your cost. If your workloads can now finish 10x faster on the same hardware, you're going to save a lot of money with these performance improvements as well. I hope you can tell that I'm very excited about this new innovation. All right, moving on from one big announcement to the next, let's talk about Workspace 2.0. This is a nickname we use to describe the evolution in our advanced feature set aimed to increase the productivity of data scientists. We have listened to our data scientist customers across many industries, and a common theme we have identified and decided to take to the next level is our DevOps workflows for data scientists. There are several different features we've stitched together for our next-gen workspaces, but I want to highlight one for you today. We now have a feature called Databricks Projects. This allows data scientists or MLOps engineers to create new or clone existing Git repositories on Databricks to carry out their work. They can quickly experiment on the latest data and easily access the scalable computing resources they need to get their job done, all while meeting security and compliance in the cloud. No more downloading sample CSVs onto local laptops, juggling private repos and hosted libraries. This means that exploratory data analysis, modeling, experiments, and code reviews can be done in a robust, collaborative, and reproducible way. Simply create a new branch, edit your code in open and collaborative notebooks, commit and push changes. Here's a quick view at what that visual diff will look like at commit time. Previously, we've offered automatic syncing with version controls, but it's just been automatic commits with each one. Now you can see your visual diffs, you can commit, you can push, you can go to different branches. Really exciting capabilities here with our new projects capability. Even thinking here of how we can get the environments to sync from your local laptops to your deployments in the cloud. We now have the ability to pip install libraries, but also, even more importantly, the ability to reuse environments by taking requirements.txt, conda.yaml files, and being able to take these definitions of your environment and reproduce them exactly how you had them locally, reproduce them the same in your deployments in the cloud, and have those reproduce across even your deployments in the cloud, meaning different notebooks, different clusters, etc. Okay, let's move on to talk about SQL analytics. You may have heard us refer to this as Redash in the past. This is a new experience coming soon to preview before the end of this year. The idea with Redash is to make things simple, seamless, and powerful. By talking with customers, we know that you have employees who are SQL powerhouse wizards, but maybe they are not comfortable with Spark and managing clusters and working in multilingual notebooks. They want their familiar experience that they're used to. So for this, we've developed a new collaborative visualization and dashboarding platform designed to enable anyone, regardless of their level of technical sophistication, to develop and share insights within and across teams. We have created a new query editor with improved schema and autocomplete. Users can even drag and drop to create dashboards to share. You can schedule refreshes and configure alerts. Take a look at this screenshot. This may look more familiar to you as a traditional kind of SQL environment. So you'll be able to switch from the standard workspace UI that you're used to and all those things, but you can also come to this experience and you don't have to think about clusters and managing whether they're on, or the configurations and the auto scaling and everything like that. You could come here and write your SQL queries as you're used to. The reason why this is so cool is you're now bringing a whole new workforce to your data lake. Instead of data engineers having to curate, aggregate, and simplify data into a warehouse or other SQL packaged environments, you can now enable all of your data analysts to leverage the full power of Spark and the data lake in a SQL-friendly environment. So look forward to this experience coming soon before the end of the year. Let's talk about the new Power BI connector that we just released. This is super exciting. You'll find it when you go into Power BI and you go to add a new connector to your data. In the Azure section, you'll see Azure Databricks listed. Here, what we've added, one of the key elements is Azure AD authentication and pass-through of these credentials from Power BI to Azure Databricks. This is super exciting because previously you had to use a Databricks personal access token. So prepare to put those days behind you, because with the AD authentication, this enables you to use your AD credentials to query and visualize data in Azure Databricks. So even better, this is supported with storage credential pass-through as well, and table ACLs. So this allows you to see only the data you're allowed to see based on table level access control, file folder level access controls of underlying storage. Your AD credentials starting at Power BI will pass through to Databricks, pass through down to that storage layer. This is super exciting. We've also added additional performance improvements, and of course this makes it for a simpler setup and sign-on experience with Power BI and Azure Databricks together. Okay, now let's take just a general look at the roadmap. I want to show you a more broad list of new innovations we've recently pumped out, and also talk about things that are coming soon that you should be excited for. All right, I won't go over everything on this list. We already highlighted a few of the top things here, but let me call out a few extras to you. One being down here, AD authentication with our REST APIs. Similarly, if you like that thought of giving up on personal access tokens with Power BI, did you also know we've released this capability to authenticate with our REST APIs using AAD user and service principal-backed tokens? So with this functionality, you can also automate your Azure Databricks deployments end-to-end. Previously, there was this awkward manual step after workspace creation where you had to manually obtain a personal access token from the UI before you could then launch a cluster. With AAD authentication with the APIs, you can now completely automate this process of deployment. And for the few things where you might still want a personal access token, we've also added a token management API, allowing admins to manage their employees' tokens, including the ability to monitor and revoke, control the lifetime of the tokens, and control which users are allowed to even create these tokens. Another new feature that we've been working on is the acronym here is CMK for DBFS. This stands for Customer Managed Keys. For DBFS is the Databricks file system. This is the default storage account that we give you when you create your Azure Databricks workspace. Of course, this storage account has always been encrypted, and we ensure the highest security measures here. But now we're also giving you the opportunity to bring and manage your own keys for that encryption. So you don't have to trust us with keys. You can manage your own key lifecycle and feel confident that your very own key is being used to encrypt your very own data. All right, let's flip over to talk about what is coming soon. Get you excited for what's coming soon. So I already mentioned that we're going to be releasing into the US government cloud as a GA release pretty soon. we released into China, and that Azure China Cloud will also bring that to a general availability release pretty soon as well. If you are still not satisfied with all the innovations we've put in for network isolation, including VNet injection, service tags, IP access lists, don't worry, we're still working on even some more to remove all public IP addresses from your deployments. So there's no public IP preview. Stay tuned for that. I mentioned the customer managed keys for your default Databricks file system. We're also releasing this for the notebooks where you author your code, the ability for you to encrypt this with your own keys also. We're working on private link, and one that I'm really excited for that I'll finish off with is spot VMs. In the near future, we plan to allow you to create Databricks clusters with what we call Azure Spot VMs. These are super low-cost VMs that are preemptible. This means that if you have a workload that's not time-sensitive and you'd like to save money, you can choose Spot VMs. We may have to interrupt your job to reclaim the VMs for a short period of time, but your job will then resume where it left off and keep moving at a very low cost. You get some steep discounts when you leverage Spot VMs if you don't have the time sensitivity of when your job completes. So this stuff is very exciting. I am very much looking forward to the future and all of the new things that we'll be sharing with you soon. Hopefully you are also excited by this innovation that I've shared with you. And this progress would not be possible without you as a community. So I encourage you, please, comment here, ask questions, reach out to your Microsoft or Databricks representatives, share ideas, feedback, or of course, my favorite is hearing about your success stories. So check out some of the links that are here on the screen for ways that you can learn more, that you can jumpstart your journey in leveraging this amazing new technology on Azure. And with that, I want to close and turn the time over to Q&A. So please ask me some questions, and hopefully I can bring some interactivity to this session and help answer things that have been on your mind.